in a sense, an alliance of humans that are working for the ocean.
Ocean planet Earth has dimmed 0.5% in just 20 years. The dimming means that ocean planet Earth is absorbing more sunlight than it has previously. It is actually heating up. Loss of marine clouds and also loss of sea ice. This combination has resulted in a lot more heat absorption. These waves, of course, produce wonderful amounts of sea spray, some of which are submicron. Permaculture approaches produce not only carbon fixation, emissions reduction, and carbon removal, but the third leg of the climate triad, and that is climate repair. Algae forests do a great job of producing biogenic cloud condensation nuclei. Our work on marine permaculture is working to regenerate the kelp forest that we've lost.
Restoration, greening up the ocean with seaweed, restore the sea otter to the west coast, and I believe also part of the North Pacific on the Russian side. They eat the sea urchins, and the sea urchins eat the young kelp. And so one of the reasons for our kelp decline is the loss of the sea otters. Everything's connected. Seagrass meadow restoration, coastal marsh restoration, coral restoration, and mangrove restoration. Those are all greening events in the ocean, and we need all of these things to be just scaled up and scaled up. We need more protected marine reserves. We need to stop overfishing and fishing methods that harm ecosystems, banning deep-sea ocean mining, the population restoration of whales and cetaceans, the role of whales in ocean functioning with their poop and vertical mixing, etc., is something that we need to spend more time on. And then taking out the Snake River dams would open up a lot more salmon spawning habitat, have more salmon, which would help our southern resident orcas whales.
The last 25 years I've been working on what I call underwater munitions. Back in 1910, started in the English Channel, the dumping of chemical weapons by most militaries of the world up until the mid-1970s. Every sea in the world is polluted with large quantities of these different types of chemical and conventional munitions. They are government responsibility. It's the government, the militaries, that put them there. I've been somewhat successful by hosting international dialogues and bringing together the international community.
I'm reminded of the neurotoxins developed and used during World War II that turned into, after the war, they converted into pesticides, including DDT, that was used extensively. Now, around the early 1970s, they developed a ban on dumping of DDT, and a few months ahead of time, off the coast of California, they took drums and drums and drums of DDT and dropped them in the deep ocean. And of course, those have rusted and leaked. And now we've got DDT spreading out across the ocean floor in these deep waters and having a profound effect on benthic sea life. So there's another example where we're seeing the results of these munition dumps happening, and it's having a profound effect on our oceans and our sea life. So it's something that we need to be aware of and actually work to address. These are the kind of problems we need to focus on to regenerate a healthy ocean and a healthy climate.
Each project adds cloud cover also over the oceans. Once you do enough of that, it's bringing down the CO2, repurposing that carbon into sea life, but it's also shading the ocean and reflecting huge amounts. It has the cooling power of 1.4 times the warming power of the gigatons of CO2 that are going up today.
John Todd's method, and learned from John Todd, that putting a variety of various species, just continuing to load biodiversity in all different forms, no special recipe, into these sequential tanks where he would sequentially detoxify the water, the chemicals coming out of the treatment plant, and got it to a place where it was just water that could be discharged into the land. The restoration of biodiversity, self-organizing. The microbes and the biodiversity just keep breaking things down into usable components.
And of course, the conversation will have to continue because we're just barely scratching the surface. We'll be building on this, and so we definitely will be back covering more of this and speaking up for the terrestrial bioregions of the world. We can help with the brightening and the cloud formation as well.
I will introduce myself. I'm John Shaw, EcoRestoration Alliance co-founder. and I will invite people to introduce themselves. And just very briefly, Michael and Leonard are our hosts for today's meeting, Ocean Restoration. Michael and Leonard, do you want to say hello? I'll hand the floor to you in a moment while I'm filling the empty time.
Yeah, nice to be here with everybody. I'm an old friend of the EcoRestoration Alliance, and I have been on so many Zoom calls with Philip Bogdanoff and John and Russ. And, so it's a feeling of coming back to old friends here. So I appreciate everybody that's with us.
He always says the nicest things. Philip, say hello. Hello, Leonard. Sorry, I beg your pardon. Hello, Leonard.
Yeah, hello. Hi, everyone. Nice to see you. I'm Leonard. I'm from Rwanda. So, yeah, I'm part of ERA, specifically Africa, and these master classes. I'm glad to be with you all.
Leonard, Phoebe, who is not with us today, and Michael organized this particular class. And we'll just continue the round robin for a minute. Philip, say hello.
Hello, everyone. Good to see you all. Philip Bogdanoff with Bio for Climate, co-founder with John of this ERA.
And Hart Hagen, also with Bio for Climate, who wishes to invite you all, as he will now do, briefly.
How much time do I have, John?
I would say just a couple of minutes, Hart.
Okay. Let's go on to somebody else. I'll condense my 10 minutes down into 2, and then you can circle back around.
Very good. Katie Ross, greetings.
Good morning, everyone. I'm calling in from Wisconsin today. It's lovely to see everybody's faces from across the world. I am adjunct at University of Technology, Sydney, and I work with Bio for Climate and a recent member of the EcoRestoration Alliance. So lovely to meet everyone.
Pleased to have you here. Russ Spear.
Hi, this is Russ Spear, just calling in from California, Oakland, California. Very nice to see everybody.
Brian, you're going to be one of our distinguished panelists / speakers today, so I'm going to skip you. Elizabeth Morgan Tyler.
Hi. Good morning, everybody. There I am.
Where you am?
Oh, I'm in Chimacum, not too far from Michael Pilarski, and I'm an activist in many ways. I'm particularly focused on water issues, and it's 6 o'clock in the morning here. So I'm just really, really glad that I woke up and saw this. Thank you, Skeeter, for sending it.
Well, you and me both. I'm also in Washington State. I got here at 2 o'clock this morning. So here we are. And I'll see Michael in the next few days. Emmanuel Chiche.
Okay, can I add one more thing? I just wanted to say that I'm also an astrologer who focuses on the sun, moon, planetary system and the importance of integrating all of our systems into holism. And I think the ocean is probably the primary. I mean, we are. It shouldn't be called Earth. It should be called water. So that's my passion, and that's why I'm up. And thank you all for doing all the work that you're doing. It's really important. Thank you.
Thank you. Good to meet you, Emmanuel.
Thank you, Elizabeth. Thank you, John. Hi, Emmanuel. I was at your meeting a few weeks ago with Aude and John D. Liu that I really enjoyed. I met a lot of new people. I'm in the design school for regenerating Earth, and I was with Brian in the Oceana Community School Sunday ago. That's where I met him first, and then I heard about the event today. I'm a permaculture designer and a woman-centered coach, and I'm based in New York City, the Lower Hudson Estuary. Thank you.
Thank you. George Orbelian.
Hi, everyone. George Orbellion. I'm based in San Francisco in the Marin Headlands. I'm currently with Rick Lukens up in Washington, and a longtime surfer, over 50 plus years, former surfboard design editor for Surfer Magazine and author on it, and founder of Project Kaisei with Doug Woodring and Mary Crowley to go after the plastic in the North Pacific Gyre in 2009. And I'm very concerned about all of the things that are happening to the ocean right now and look forward to working together. Thank you.
Thank you. Jonathan Cloud.
Hey, good morning. I'm pleased to say it's hi, Emmanuel. It's a civilized 9 o'clock in the morning where I am in Rochester, New York, John's hometown, and I'm the executive director of Possible Planet, and we're a fiscal sponsor for the Design School and other projects around the world. I'm very happy to be here and see John and join this program. It's exciting.
Thank you very much. Sumitra Das.
Hi, good morning. This is Sumitra Das, from founder of Healthy Climate Initiative. I have been working with Brian for several years, invited me to this program. Very happy to be here.
Thank you, Sumitra. Mary Minton. We are reaching.
Hi, my name is Mary. I'm actually just a very interested observer. Water is my middle name. I just moved very close to the Salish Sea. I'm also in Washington State and grateful to be able to learn from all of you. Water is just, it's why we live on this blue planet. I'm so grateful for the work you all do. Thank you.
Thank you very much. Louise Mitchell. Okay, Louise, hello.
Good morning. My name is Louise Mitchell. I'm with BioDiversity for a Livable Climate. I'm the Outreach Programs Manager. Nice to see all of you.
Thank you. Scott Edmondson.
Good morning. I'm Scott Edmondson. I'm with Pacific Northwest National Labs. I'm a research scientist.
Great to meet you. Howard Langeveld is connecting to audio, so we will ask one of the Edibs to introduce themselves. And next will be Ruth Diaz, who can jump in if Edib does not make noise. All right, then. It is 6:11. We have a distinguished audience and a distinguished panel, and I'm just going to pass this to Michael for introduction, and Leonard.
John, did you want me to introduce?
There you are. Oh, yes, and Hart is now prepared to make an announcement and invitation.
And could I please have up to 3 minutes? I'll be as efficient as possible.
Yes, sir.
Okay, thanks. So this is an invitation to the Water and Climate course. It's the 5th course I will have taught with Biodiversity for a Livable Climate, the untold story of how water governs our climate and what climate models miss about the power of water. We have an all-star lineup for guest speakers, including Anastasia Makareva, and this is a 4-week course with twice per day. So that's how we fit 5 speakers into 4 weeks. Anastasia Makareva, Walter Yana, Brock Dolman in California, Katie Ross from Wisconsin via Columbia and Australia, Dee House from Vermont, who's also done work on how we can rehydrate California. We'll talk about the dominant climate change narrative and provide an alternative to that. We'll talk about what is the greenhouse effect and how could plants and the cooling systems that they bring can eliminate the greenhouse effect if we have enough of them and if we have enough diversity of plants. We'll talk about, what happens when you have hot surfaces and what are the alternatives to hot surfaces, not least of all in our farmland. Well, these are the four ways in which ecosystems drive water cycles. We'll talk about each one, and so that we'll know what's lost when we remove a forest. These are at least 9 things a forest becomes as it interacts with water. And what are the effects of deforestation? Hint, a forest is not just carbon. This is an excellent report from the World Resources Institute. And we'll talk about drylands and desertification, because not everything is a forest. Not every place wants to be a forest. Drylands deserve a different set of strategies and considerations. And we will, one of the things you'll get is the best resources in this space, including this 5-minute video sponsored by John Schull and EcoRestoration Alliance by Jimmy Soul Eisenstein, How Plants Could Save Us. And so this is an invitation to the course, and please check out these 2 links in the chat. The course itself with a link to the BioDiversity for a Livable Climate website where you can check out the description and register, and also testimonials from many of my students, including have had PhDs, lawyers, doctors, leaders, one doctor, leaders from nonprofit space, etc. So I invite you to check that out. Thank you very much for your time.
Thank you, and well done staying within your limit. I failed to do that myself on occasion. And congratulations on a stellar lineup. Really great. Okay, Michael, Leonard, take it away.
Yeah, I would suggest Leo gives a little bit of background for the master classes and where we're at here. Let's see, you're muted though.
Oh, sorry. Yeah. Thanks. Hi, everyone. Thank you so much for this opportunity. I think, the Masterclass, it's an initiative of EcoRestoration Alliance. It's, I may say, a planned class that we have in different topics. And so far we had 3 of the classes, and today we are going to be discussing about ocean restoration, and also in the future we'll be having some other topics like medicinal plants, agroforestry, compost, regenerative agriculture, and so many others. So if you feel like you have a certain topic that you want to teach to the people, please feel free to reach out, because there is so many room for speakers and for knowledge sharing activities like this that we are going to have. Briefly, that's all. But also keep your eyes on our social media, like LinkedIn and the others, and we share this recording after on our media and also on YouTube. Yeah, thanks, Michael.
Okay.
We should also give credit to. We should also give credit to Phoebe Barnard and the Global Research Collaborative, the GRC, for helping to organize this. And Michael, off you go.
Okay, so if I had one of my indigenous friends here, I would have him offer a prayer, but since I don't see any of them here, I'd just like to offer a prayer for a good outcome from our meeting today, and wish that the ocean will be here represented and all the ocean spirits, because they're a big part of the world. And so we're, in a sense, an alliance of humans that are working for the ocean. And so I'd just like to acknowledge that and thank the ocean for keeping us all alive. And so today I really wanted, I'm working on a global earth repair convergence with the goal of producing a set of recommendations for the world on how do we get ourselves out of this fix. And so today was going to be trying to look at recommendations in terms of ocean restoration. So if people, when they're talking, could use the term something like "I propose" or "I recommend," so that we can sort of get it sort of a record out of this. How many policies, recommendations can we get out of this one class here? I have a number of my own. But at any rate, that's part of what I'd like to see come out of this, is actually something that we can publish as a set of where we'd like to go. I don't see Peter with us yet, but the lineup is Dr. Brian von Herzen will start first, and I'm really thrilled that he's here. Russ George will be, if Peter shows up, he would be next, and then otherwise it would be Russ George before we open it up to the general group to add their comments or questions. So, Brian, you're a familiar person on the ERA and a distinguished scientist, so we're really keen to hear what you have to share with us today.
Oh, thank you, Michael. It's great to be here. Calling in from Jeannie-Barra territory, and that's the hinterlands of the Sunshine Coast of Queensland, Australia. I'll ask everyone to take a big breath in and a big breath out. And let's do that once more. Breath in and breath out. Ocean, planet Earth. Every other breath we take is coming from the ocean. That is how profoundly we depend on the ocean for our very survival. The oxygen that we breathe, the food that we eat, and the climate that we enjoy. With that, I will share with you some of the insights developed with Dr. Sumitra Das, who's with us today, in our work at the Climate Foundation, the Healthy Climate Initiative, and our new project, Rebrighten, which is working to rebrighten ocean, planet Earth within our lifetimes.
Could you speak louder, please?
Yes, thank you for that feedback. I can just turn up my gain on Zoom. One moment. All right, let me know if that's too loud. And I will share my screen. So as I mentioned, Dr. Sumitra Das runs the Healthy Climate Initiative. I work with the Climate Foundation, and we have a new volunteer project, rebrighten.org, which is working to rebrighten ocean, planet Earth. Believe it or not, ocean, planet Earth has dimmed 0.5% in just 20 years. Our planet is dimmer and duller than it was just 20 years ago. How do we know this? From the NASA Ceres satellite and the Big Bear Solar Observatory. They show this dimming. The Big Bear Solar Observatory has actually measured the dark side of the moon, which reflects light from the Earth. And that sunlight has dimmed by 0.5% in the last 20 years. This data is profound in showing this dimming, because the dimming means that ocean, planet Earth is absorbing more sunlight than it has previously. And because it's absorbing more sunlight, it is actually heating up. There are several reasons for this, including loss of marine stratocumulus clouds, especially near the equator and subtropical latitudes, and also loss of sea ice. This combination has resulted in a lot more heat absorption, and that increased heat absorption has had a profound effect on both the temperature of the ocean and on the poles. And this is an animation, I believe, from NASA showing what's happened up near the poles and how over a period of, I guess, close to 50 years now, we've seen the natural reflective cover of the Earth diminish up and under the North Pole, and now more recently, we've seen this happen with the Antarctic ice sheet. And unless we can reflect all the sunlight back, as nature has done for years and years, we're going to be facing dramatic warming, as we've seen in terms of the difference just since the mid-2010s of the increase in absorbed solar radiation versus the emitted solar radiation. And this difference, which has quadrupled in the last 20 years, contributes significantly to the increase in temperature of the ocean. In some cases, at some latitudes, it's gone up even more than a factor of 4 in the last 20 years. And this represents a big deficit in our thermal budget, to the point where people are proposing moving from a CO2 vertical axis to a radiative balance vertical axis, as shown on the left on this chart. Watts per square meter becomes the metric rather than pure CO2 equivalent. And that is an interesting proposition because it emphasizes under this watts per square meter basis, the agriculture or the loss of forests on our planet grows from 40% to 60% of the issue. And in addition, it raises the idea that by rebrightening the planet, we can actually address the thermal imbalance while we're getting our carbon budget back into balance. So this is a profound challenge that we face to address this. We're seeing 93% of planetary warming going into the ocean and having a profound effect. And in fact, the International Maritime Organization over the last decade has cut sulfur aerosols over the oceans by 80% or more. And that has resulted in a decrease in sulfate, which has had a profound effect on not only the sulfate emissions, but actually has had a profound effect on the ocean warming temperature. It took just 6 months from January 1st, 2023 to, I believe, July, when we saw ocean temperatures in the North Sea anomalies exceeding +5 degrees Celsius, and temperatures in the Florida Keys exceeding 101 degrees Fahrenheit, which is enough to not bleach, but kill the first coral reef I ever visited, and that is the Sombrero Reef off Key Largo, and most of the other corals in the Florida Keys. So a very profound effect. We can see in a nutshell in this animation the increase in temperatures over the last century. And this shows a month-by-month, year-by-year diagram of the temperatures on oceans and climate that have occurred from the 70s up through the 2010s and 2020s. And you'll notice this cone shape as we go up in the years, a profound difference in temperature that is super linear and has a profound effect on what we're doing. So that, in a nutshell, covers many of the issues. One of the profound effects, actually, has been that the ships that crossing the North Atlantic, North Pacific Oceans have had a significant factor in providing aerosols that did, in fact, reflect more sunlight into space. And yet we've lost many of those. The sulfur emissions have dropped dramatically, and the result has been profound warming, in particular the years since the IMO edicts started being issued, in which case we've seen a very sharpening in the morning, a very strong sharpening, with response times on the order of 6 months, as evidenced by the beginning of the program here. And in fact, January 2023 was when it changed. And the latest chapter is that the IMO has imposed these regulations on the Mediterranean effective May 2025. So we're likely to see profound differences there in what has amounted to a very large experiment. As a result, there are a lot of challenges. I'm going to skip down to some potential nature-based solutions that we can consider, inspired by Michael's suggestion. And that is, it turns out, if you just look up and down the beach on a bright sunny day, you'll notice haze up and down the coast as a result of natural and biogenic aerosols that are produced by the ocean each day that do a great job of providing marine cloud condensation nuclei and helping to form marine clouds that actually contribute significantly to reflecting sunlight back into space. And we can look no further than the beautiful waves that George and I love to ride when we can. And these waves, of course, produce wonderful amounts of sea spray, some of which are submicron. The late great Stephen Salter proposed doing this on ships as well, and that can include dedicated ships as shown here, or ships of opportunity that exist in the ocean. And I'll add briefly that our work on marine permaculture is working to regenerate the kelp forest that we've lost over the last century. In fact, 90% losses off the coast of California, the west coast of the US, and we can document more than 3,000 square kilometers of lost kelp forest in the US and Australia alone. So these are profound changes caused by a warming ocean and a warming planet Earth. Fortunately, we've developed some marine permaculture approaches that can, in fact, produce not only carbon fixation, emissions reduction, and carbon removal, but the third leg of the climate triad, and that is climate repair. These algae forests do a great job of producing biogenic cloud condensation nuclei based upon molecules like mercaptan, isoprene, and dimethyl sulfide. These natural compounds that are produced naturally by the seaweeds shown here actually contribute to marine cloud formation, cloud condensation nuclei that have a profound effect on rebrightening our planet. And so when it comes to a prescription for regenerating ocean planet Earth, I have found a few suggestions, and that is in our locales and our regions, we work to rebrighten our marine clouds with a combination of biogenic cloud condensation nuclei from our kelp forests and submicron sea spray. Modi has pledged to increase the production of seaweed in India from 30,000 tons in 2024 to more than 1 million tons in 2025. That's a good step, but we have to go further. We need to demonstrate that once if by land, twice if by sea, we can rebrighten the planet. I will note with interest that pine forests are excellent at producing terpenes that form cloud condensation nuclei over mountains, and sesquiterpenes in particular are a particular class of biogenic cloud compound that actually helps form these orogenic clouds as well. So with that, I will encourage us to rebrighten our ocean planet Earth physically, morally, intellectually, and morally in our days ahead, and look forward to the conversation on how we can rebrighten our planet and lead and regenerate and restore a healthy climate. Thank you.
Well, hurrah, Brian, for that. I was like, well, he's just getting started and his 10 minutes are up. But actually, you finished admirably there. Though we could obviously like to, you should maybe do your own master class sometime where you have something. You may actually have something online. Do you have a much longer presentation like this that you've done that we can access somewhere else?
Yes, there are several on YouTube, and happy to share that as we go. Thank you, Michael.
Hey, great. Yeah, it'd be good to have those for our resource list. So I'm going to take a few minutes here. I'm going to do a quick screen share as well. Let's make sure I can do it here. Let's do share.
Michael, I wanted to let you know that David Millark has joined the presentation, founder of the Archangel Ancient Tree Archive.
Oh, wonderful. Wonderful. I haven't talked to him, but wonderful work. And maybe after Russ George, we're going to open this up, and so he could be great to have him say something. If Peter Fikowski doesn't show up, that gives opens that space up. Okay, let me go here to PowerPoint and view my slideshow, and you can tell me if you're seeing this.
Yes.
Okay. So I wanted to show you a quick photo of where I'm actually from, the Methow Valley in north central Washington in the Cascades. And you can see how dry it is in the foreground there. We're 15-inch rainfall. So I am a landlubber and don't know much about oceans, but I realized that I'm much more of an expert in terrestrial systems, but recently realized that restoring the Earth needs a lot of focus on restoring oceans. And so this particular masterclass here is sort of just testing my waters here. So one of the ways to restore the oceans is to actually restore the land and restore the all the streams, rivers, fresh waters that flow into the ocean, because the pollution and the sediments that come in to the ocean from the land, from the rivers, is an important part of the problem. And so restoring the land will help restore the ocean. And I used to say greening up the land is our main motto for Global Earth Repair Foundation. But I realize now it's also greening up the ocean is a very valid slogan as well. And we'll see different ways I talk about greening up the ocean here. Here's a phytoplankton bloom in an ocean eddy from satellite. You'll see there's some more off to the right here. And I know that I'm going to go back here, that the mineral dust replenishment of ocean pastures is one way of talking about what Russ George and quite a few other people are talking about. How do we use mineral dust to replenish ocean pastures and improve situations in the ocean? It's according to a lot of reports, it's maybe the fastest way the phytoplankton offers one of the fastest ways to draw down carbon, increase bio-aerosols, and improve the situation on Earth quite a bit. And so, and I know it's really controversial, but it's not so controversial to me. I read this book, The Survival of Civilization, in 1982 when it first came out, 43 years ago. And in this book, John Hamacher lays out the thesis that the glacial ice ages grind up a lot of dust, and at the end of the ice ages, there's a lot of wind in the world in the settling out period, and the whole Earth is remineralized by these dust particles. It's a remineralization. This remineralization has been talked a lot about since then. In the agriculture sector where I am, we talk a lot about adding minerals to soils to improve their functioning. And so the idea of minerals being really important on land ecosystems for healthy functioning is something I've been living with for 43 years. I also am a health nut, and I know that mineralization in the human body is really important for our health. And we eat demineralized foods, and we have demineralized humans. That means unhealthy humans. So the idea that minerals can help the ocean ecosystems is you might say, no-brainer for me. It's something I really say, oh, yes, that makes perfect sense to me because of my studies on mineralization in other parts of the globe. And seaweed restoration, greening up the ocean with seaweed. Brian referred to that, and I think that seaweed restoration is incredibly important. And one of the things I'd like to see us do is restore the sea otter to the west coast, and I believe also part of the North Pacific on the Russian side. They eat the sea urchins, and the sea urchins eat the young kelp. And so one of the reasons for our kelp decline is the loss of the sea otters. Everything's connected. And other parts of regreening the ocean, seagrass meadow restoration, coastal marsh restoration, coral restoration, and mangrove restoration. Those are all greening events in the ocean, and we need all of these things to be just scaled up and scaled up. And obviously, if we're going to have a healthy ocean, we need more protected marine reserves. We need to stop overfishing and fishing methods that harm ecosystems. I know George Pletnikoff was referring to the trawling methods in the North Sea and the Bering Sea that are just really ripping the ecosystem apart. And I came up with a new thing I don't have in this list here. Banning deep sea ocean mining, I think, should be one of the recommendations list. Give special care to the population restoration of whales and cetaceans. The role of whales in ocean functioning with their poop and vertical mixing, etc., is something that we need to spend more time on. And then on a more local level here, taking out the Snake River dams, which is a subsidiary to the Columbia River, would open up a lot more salmon spawning habitat, have more salmon, which would help our southern resident orcas whales. So it's sort of a recommendation that's just about our particular parts of the globe. And so there's big things like increasing clouds, ocean brightening, phytoplankton blooms that are sort of like on a global scale. You could make some recommendations, but we also need recommendations that are at a more local scale, regional scale. And so we hope that we'll get more of those as this movement comes along here. So I think that was my brief. I'm going to stop share them and come back to here. So I see I did that in 6 minutes. Not bad. So that's just a few of my recommendations. And of course, we need to really flesh these out. Now, I don't see Peter Fikowski here at this point, unless somebody else does. I think so. I'd like to turn it over to Russ George for a little bit here. We were talking 5 minutes, George. Maybe you could go a little over, but I know that you're one of the foremost champions of the remineralization of the ocean. So if you could give us just give us a sneak preview of what you're thinking.
Okay. All right. Well, my name is Russ George, and I've been doing eco-restoration ever since I got out of college as a plant ecologist 55 years ago. I started a tree planting company in the early 1970s, which became the second biggest tree planting company in Canada. So still carries on today, although I sold it out many years ago. But we planted hundreds of millions of trees all across Canada. And a number of years ago, I got asked to look into how many trees we could plant on land to reduce the carbon footprint of the Canadian energy industry. And I spent about $2 million of the oil industry's money doing a comprehensive study, trying to find enough land in Canada so that we could have a massive tree planting program that would reduce their carbon footprint. And I had to report to these 6 different oil energy majors in Canada that I couldn't find enough land to plant enough trees to make a dent in their fossil fuel carbon footprint. And that was the bad news. But I told them about John Martin, who had been talking for decades about restoring ocean plankton blooms and about the crisis of ocean plankton, which is the grass. Phytoplankton is the grass of the ocean and of the ocean pastures. And John Martin back in the early 1970s was part of a team that was charged with discovering more about ocean plankton. And so they designed and built and launched into orbit the first ocean plankton ocean pasture satellite in 1978. And that satellite showed that the growth of ocean plankton was in a sharp decline. The spectacular decline had been going on for decades already. And since 1950, roughly, since the industrial age, carbon dioxide started pouring into the air, plankton has been disappearing in the oceans. And the link between carbon dioxide and ocean plankton die-off is that carbon dioxide feeds grass on land. So Skeeter knows that dust comes from grasslands, not forest lands, right? And when grass dries up and gets brown and dry in the hot season and the wind blows, the dust blows in the wind. But the steady increase of CO2 in the planet prevents grass from drying up because grass breathes just like you and I do. We breathe in carbon dioxide, exchange, and the plants breathe in air. Sorry, we breathe in air. Plants take the carbon dioxide out of the air and exhale the oxygen. They do that across a wet membrane, just like our lungs have a wet membrane. And every breath they take, they breathe out moisture. It's called evaporation, evapotranspiration. So more CO2 in the atmosphere means plants have to take in less air to get the CO2, their requirement they need to survive. So the high and rising CO2 has been like a gentle rain that's been falling all over the earth. It helps trees grow, but trees grow really well anyway. But grasses are desperate for moisture. They're controlled by moisture more than anything else. So more grass growing on dry lands of the world means less dust is blowing in the wind. And that decline of dust that's been caused by the increase of grass growth around the planet, and this is really well established in the science of agronomy, grass science. It's not at all in the science of climate change or meteorology, but in agronomy, this is the driving topic, is evapotranspiration of grasses. And so the collapse of CO2, of the increase of CO2 has caused the collapse of wind-blown dust in the air. So China today, we've all seen pictures of dust storms blowing out of China, right? And it makes the news. Well, China today has 80% less dust blowing out of China, out of Mongolia and China today, than it did 50 years ago. That's an 80% decline. And that 80% loss of mineral dust, that mineral dust from China is the primary source of vital mineral nutrients for the vast bulk of the North Pacific Ocean, right? And even the North Atlantic, north of Bermuda in the North Atlantic, the primary source of mineral dust comes from the Gobi Desert, not from the Sahara, right? So the Northern Hemisphere oceans depend on dust that blows in the wind. It's down by 80%, right? So there's no mystery to imagine that the ocean is not growing well. So if I share a screen here, I'll show you there's a story that just came out in the media this week. A great scientific article was published in a major journal about global change biology, about ocean acidification happening and the problem. And the article is an incredibly long, dense article. And being an ocean scientist, I found it very challenging to read. But what's happening is it says the ocean is acidifying. Well, I dove into this because it's been a passion of me. They talk about the disappearance of little small organisms in the ocean called pteropods, sea angels, whose shell can no longer be formed. So they've all but disappeared in the world's oceans. And what happens in this story, and I'll post a link to this, is the plankton, when they grow in the ocean, compete for carbon dioxide that makes the ocean acid. So every molecule of CO2 that goes into the atmosphere eventually ends up dissolving into the ocean. And H2O plus CO2 turns into H2CO3, which is acid, unless something competes for that CO2 molecule in the ocean. And it formerly was phytoplankton that was seizing that carbon dioxide molecule, preventing it from becoming acid by turning it into more ocean life, into more phytoplankton. So the collapse of here's a chart of I just did. Thank God for AI. I was able to build an ocean acidification model just a week ago or so. And so if we were to the yellow, the red lines and orange lines, the lower lines are the projection of the increasing acidity of the ocean from today onward, roughly, right? In scenarios, if we reduce the amount of CO2 emissions from fossil fuels, so if we do nothing, right, we get to about at 2095, we get down to the lowest pH, and if we take 10% out of the atmosphere, if we take 10%, we end up here. If we take 50% of fossil fuel emissions, we eliminate them, we end up here. So we're cooked, right? Even if we try to eliminate fossil fuels, but if we can restore ocean plant life, right, and add restore the dust to the ocean. The dust isn't enough. It's not a single silver bullet. It's not going to save us from ocean acidification, which, by the way, at pH 7.95, that's the general consensus. That's the literal deadline for the vast majority of ocean life, right? So the deadline, if we do nothing, is 2045. If we reduce 10% of our fossil fuel emissions, we make it to 2050. If we reduce 50% of our fossil fuel emissions instantly, I mean right away, tomorrow, we make it to 2060 before we cross the deadline for the ocean, right? But if we do dust replenishment to the ocean, right, we make it all the worst case scenario for dust. If we do a little bit of dust replenishment, we make it all the way up to the end of the century. So we buy time. If we add 10% of the, if we add a 50% fossil fuel emission reduction to the addition of mineral dust, we make it, way out here. So we stay above the deadline for a long time. So the message is that we simply have to stay above this deadline, the ocean. And the only mechanism, no amount of fossil fuel emission reduction, right? No amount of solar power, no amount of wind power, and that is killing fossil fuels tomorrow. Nobody thinks we're going to kill fossil fuels tomorrow. So nothing that we can do in the fossil fuel world will save us, because in all of our yesterdays prior to the present day, the world has burned enough fossil fuel to put 2 trillion tons of CO2 into the atmosphere. CO2 takes hundreds of years to convert into ocean acid. It's a very slow process, but it's steady and relentless. It does not stop unless something stops it, competes with it. So the only hope for this blue planet is regreening the ocean. And the only mechanism to regreen the ocean is to restore its missing dust. So that's what I've been working on. So I went out I first wrote a report on this for the Canadian fossil fuel industry in the year 2000. I went out on my first ocean mineral dust replenishment project in 2002, because my good friend Neil Young, a rock star, had heard me talking about this, and he says, why don't you just get off your butt and do it, Russ? And I said, well, I don't have a boat big enough to do it. So he loaned me his 150-year-old Baltic schooner, the Ragland, and so with Neil's, help, I did my first ocean dust experiment that got written up in the journal Nature in 2003. I was able to raise millions of dollars and buy a former NOAA research ship in 2006 with the help of a bunch of investors. We launched our first voyage of ocean recovery that year. We got ripped up one side and the other by the green movement and the anti-climate change movement, who said, you can't do this. If John Martin said, he said in 1990, John Martin who was the father of this work, had done the math. He said, if we replenish the dust, the mineral dust to the ocean phytoplankton will restore the life of the plankton in the ocean, and the plankton will suck CO2 out of the atmosphere with such power that it will cool the planet. And he'd done a lifetime of study on this, and he had shown that dusty periods that followed ice ages, like Skeeter was talking about, where there was mineralization from glacial dust blowing in the wind, right, had repeatedly dusted. The ice ages were begun by dust blowing in the wind, which dusted the ocean, which caused phytoplankton to grow in the ocean, which pulled CO2 out of the atmosphere, cooling the planet, pulled the CO2 greenhouse gas blanket off the planet, cooled the planet, and the planet went into an ice age. And John Martin showed this through ocean chemistry and sediment records, that this had happened through numerous ice ages. And he did the math, and so he gave a major paper at the big ocean science conference one year, and he said, the phytoplankton global warming is the biggest problem on the planet. This was in 1990. But the phytoplankton can control this global warming problem. He says all it will take is a half of shipload of iron, of mineral dust, that we need to restore to the ocean, replenish to the ocean. That will be sufficient for the ocean phytoplankton to grow, to rebound and grow. And the phytoplankton will pull enough CO2 out of the atmosphere to force the planet into a new ice age. So to take us off the track of global warming and cool the planet. And so I have to put it into context, right? A half a shipload, that's about a ship carries about a big ore ship of iron ore, for instance, mineral dust, is about 200,000 tons. So a half a shipload is about 100,000 tons. Well, China buys from Australia iron ore to make steel every year. China buys 600 to 700 million tons of iron ore dust every year in order to make the steel that the world uses. So just one half, and so if each of those 600 million ships is 600 million tons is 6,000 shiploads, right? So I think that's what the number is, right? If only one half of one of those 6,000 ships were used every year to remineralize the ocean, to replenish the mineral dust in the ocean, it would provide sufficient cooling power to offset global warming. So it's a spectacular issue, and it's the single most important thing. So I did the biggest project in the world in 2012. We took 100 tons of dust, myself, in a native Indian village in northern British Columbia, a Haida village on an island. It's called Haida Gwaii, right on the Alaska border. They're the people of the salmon. Their salmon had disappeared, so we created a company called the Haida Salmon Restoration Company. We put together a project. We spent 4 years with government review. We had the National Research Council of Canada funding 50% of the science. The federal government of Canada issued all the permits, was funding the project. Sorry, Skeeter, I'm going long, huh?
Yeah. You should, you're really getting our appetite, but we don't need the whole, we only have time for the introduction.
I'll wind up. We took 100, the village, 11 of the villagers and myself, we took $72,000 worth of mineral dust to the Gulf of Alaska. We distributed over an area that turned out to be about 50,000 square kilometers of ocean in a large ocean eddy. the ocean turned from blue to green. The very next year, the Haida Salmon Restoration Company, which was our company's name, experienced in Alaska, instead of catching 50 million pink salmon, which was our target species, Alaska stopped catching fish after catching 225 million. The largest catch of pink salmon in all of history, all because a tiny village of 850 native people and myself and 11 of us went out to sea and spread 100 tons of rock dust in the ocean to bring back the fish. And it brought back the fish by taking 100 million tons of carbon dioxide out of the atmosphere and repurposing that CO2 into ocean life, which would have otherwise become ocean acid. So this is the single most powerful nature-based method of the eco-restoration on the planet, right? On this blue planet. So that's my proposal, right?
Thank you, Russ.
Okay, thank you, Russ. Maybe you could stop the screen sharing here.
Yeah, I'm trying to.
And so,
yeah, okay.
Yeah, it's great to have you on board here because, as I mentioned earlier, I think this is one of the most important ocean restoration or planetary restoration things we have going, and will, of course, cause a lot more. There'll be more debate to be had here, but it's really a good introduction to people here, and having your resources will be good. But we only have a half hour left, and so usually as part of our town halls here, what we'd like to do is open it up and for other people, at least to start with, people who are already involved in ocean solutions of some kind, to maybe throw in a few more recommendations here. But before we open it up, I just want to maybe ask Brian. He mentioned the sulfate emissions from the shipping oil that they've gone to low sulfur fuel in the tankers. So maybe should one of our proposals be that we add back that high sulfur oil to power the ships, or is that just where it sounds like it was maybe a good move ecologically in one sense, but maybe a bad move in terms of planetary warming? Just a quick comment on that.
Right. The sulfate aerosols do cause harm near cities. The fossil fuel emissions are attributable to about 8 million deaths each year. So it is significant. But those aerosols show us the way. In other words, there are plenty of benign nature-based aerosols that include submicron sea spray. And, the coldest, according to Mark Twain, the coldest winter he ever spent was a summer in San Francisco. Well, little did we know that there was an order of magnitude more kelp off the coast of San Francisco in the 1800s than there is today. And we had no idea about the ecosystem services that were being provided by that kelp forest in the way of biogenic cloud condensation nuclei, in addition to the other two legs of the climate triad. And Russ George, of course, has very well articulated the opportunities for carbon removal with the microalgae plankton forests and the macroalgae kelp forests of our oceans. But in addition, with our agriculture, we can use marine products to actually reduce our emissions, which is the first leg of the climate triad. And the third leg, we have to recognize it's going to take decades, if not centuries, to actually get us back to a healthy climate when it comes to emissions to zero and 2,400 gigatons of carbon removal. What we know now from the IMO giant experiment is that in just 6 months of having put a new policy in place on rebrightening our planet, we can get our temperatures back into a range that will sustain civilization that's consistent with the temperatures and environmental conditions that our civilization developed on. And while we're getting our carbon budget back to balance, we can actually rebrighten our planet in the meantime, on sea and on land. So I think there are benign aerosols that'll do the trick, and we should rebrighten ship tracks with sea spray, and rebrighten our coastlines with algae aerosols.
And I like the pine forest terpenes too. I'm I'm on the link right here.
And there's some good articles. I do want to say one more thing, and that is the forest that Russ George produced is also a prolific producer of biogenic dimethyl sulfide, captain, and isoprene. And so those algae forests, those microalgae forests, are significant contributors to marine cloud condensation nuclei as well.
Okay, I see John has his hand up.
Yeah, I just wanted to mention one factor that is covered in the white paper that I put into the chat, co-authored by some of today's panelists, as well as Howard Dryden, is the toxic brew of pesticides, fertilizers, and the surface microlayer, which is a fingernail-thick, unique ecosystem that covers the skin of the ocean. Unfortunately, microplastics collect on the surface, and they attract pesticides and fertilizers, and all of the plankton who go up and down every day to breathe oxygen through the surface layer are exposed to that toxic mix. And that turns out to be a serious threat to the oceans as well. So my recommendation would be don't forget microplastics and the runoff, which is poisoning the oceans, which in complement to these other prescriptions makes for a pretty balanced therapy for our healthy oceans.
Great, thank you for that, John. So if anybody else that wants to chime in at this point with any recommendations or questions, or if you would raise your hand digitally here under React, that would help us sort of get a lineup here. And so I'm assuming that there's some other people here that would like to share something. So let's have a little bit more voices here. I see Louise first, and then George.
Okay. Three questions. Well, 2 questions and a comment. So, Dr. von Herzen, is there any maybe promise that the Miyawaki method poses to restoring those pine forests you talked about? Just because I think of rate of growth and the rate of growth of trees, there is a model that many on this call, and I think even from Forterra are talking about remineralizing the soil that increases the rate of growth of trees. But I'm just curious about some of these options for increasing the rate of growth of trees that would then increase those aerosols you're talking about. The second question to Russ George is about why is it just iron dust? And the third comment is, I have a vision for a press release going out from the ERA with all these promising nature-based solutions, and just pointing to what more work and more focus on these promising initiatives during this time of the UN Oceans Conference. So journalists looking to write about what's happening at the Oceans Conference get attracted by another kind of renegade alternative set of solutions that are not being presented at the UN conference, and maybe that's even part of what the headline is, including what Tom Garreau was supposed to present about. So anyway, I don't know if any folks, we have the capacity this week, but the UN conference ends on Friday. So I'll stop there. Thank you.
Yes, well, thank you, Louise. Those are great points. And I think we can touch on each of them. One of the winners of the X Prize for Carbon Removal, and we were very honored to have a milestone award from that X Prize, was actually for remineralizing the croplands of India. And it actually had interesting effects on improving the crops, but also interesting effects on uptake of carbon dioxide, because they were remineralizing with, I believe, various minerals that contribute to forming calcium bicarbonate in the oceans, which actually, for every calcium ion, it takes up 2 carbon dioxide molecules instead of 1. And so by converting calcium carbonate, the cliffs of Dover, if you will, to calcium bicarbonate dissolved in the oceans, you can actually take up 2 carbon dioxide molecules with a lifetime in the oceans of 100,000 years. So that's significant. Now, on land, I'm glad you mentioned reforestation, because it turns out about 24% of the land area is turned to farmland. And that represents about 500 gigatons of missing trees, of missing forest, which is a lot. That's about 20% of all of our emissions to date. And that land use change, we're at the cusp of something brand new, and we're doing a book club over the coming 4 weeks that I encourage you to get in touch with me about, on a new book out by one of my colleagues from Stanford University, Tony Seba, and his colleague James Arbib. And this book, called Stellar, describes how we can feed the planet using 2 orders of magnitude less farmland than we have today, using precision fermentation and precision agrivoltaics and other techniques. And this presents a huge hope for humanity, that we can in fact feed everyone, regenerate ecosystems for 8 million species, and we do that, we can rewild most of the farmland that we have back into forest and regenerating biodiversity. So this is a huge opportunity, and I encourage all of you to go out and get a copy of Stellar. Let's read up on it. And we just finished a book club in the last day, and I'm going to be leading and hosting a book club in 4 weeks' time, coordinated by Herb Simmons in DC, and part of the Healthy Planet Action Coalition. So let's all get together and read about how we can regenerate a healthy communities that'll help to regenerate healthy climate. You had 2 other points. Remind me on your second and third points, and I'd like to just touch on those briefly.
Well, the second one might have been for Russ, but Russ was talking specifically about iron dust, and then I was talking about a press release.
That's right. And so on the second point, there are different parts of the ocean that are limited by iron, or limited by vitamin B12, or limited by nitrate. And so speeds and feeds, there are places, for doing this that work best. The high nutrient, low chlorophyll regions that Russ has worked in the past are particularly conducive for micro minerals like iron. And there are other regions where you need vitamin B12, or you need other minerals, or even macronutrients like nitrate. And so I think there's a prescription for the ocean, and we should be physicians of the earth and figure out what we need to add where in order to regenerate the plankton forests as well as the kelp forests. On the third one, we actually have a proposal. We're proposing for the creation of a bright blue fund that will work on rebrightening our blue planet. And actually we're calling for $100 million to actually conduct the kinds of projects that we needed to rebrighten our ocean, planet Earth. So that is going out this week in Monaco. I think we should do a press release. We're happy to participate and help make that happen. So thank you, Louise. Great suggestions.
I see.
If I can answer Louise's question. Oh, sorry.
Go for it.
Yeah, Louise, the iron happens to be a catalyst type of action with photosynthesis. So my work and a bunch of other people who have been working on this for the past 35 years, the people who have actually done the hardcore experiments out at sea, we see that for every atom of iron that we replenish to the ocean that empowers photosynthesis, we see ocean photosynthesis captures at least 1 million molecules of CO2. So it's 1 to 1 million ratio. So that's why iron-rich dust is key. And iron's important for photosynthesis because it sits in the middle of the periodic table, and it manages electrons better than other atoms, right, at other ends of the table. So there's a process there. But iron is Mother Nature's magic dust, right?
Great. I see George Orbellian has his hand up.
Yeah, thank you. I know Tony and James, and that's a great book, Stellar, and their work at Rethink X. They also did a very cool little 32-minute movie called Rethinking Humanity that's on their website. It's well worth watching. I wanted to also let you know that I invited Terrence Patrick Long from the International Dialogue on Underwater Munitions to this call. I see he's joined, and maybe David Millark can say something as well as Terry. But I wanted to bring one main thing to this group. In everything humans are proud of having accomplished, there's one thread that runs through it all. Think about the Wright brothers, and now we have the James Webb Space Telescope. Think about the horse and buggy, and now we have Formula One cars and cars that drive themselves. Everything we've built has always been based on precision measurement. The one area we have not applied precision measurement is the relationship between humans and the ecosystem. We now have the data that is helping us understand what is actually going on this planet. But we need to create codes and standards that reflect best practices and have those set with precision measurements so that they can be defended in court and so that they can inform policy. So that, and then the other thing haven't heard about yet is what's going on with the Fukushima water that's being released into the Pacific. The deep seabed mining, the oxygen project that's being done by Vassar Seidel, who is the granddaughter of Ted Turner, and then thawing permafrost, as well as the thawing Arctic, and the forever chemicals, as we know. So thank you. Look forward to working together.
Thank you, George.
So I see Russ has his hand up, and then George, you mentioned a person that should hopefully raise their hand to go next.
Yes, this is Russ Spear. The X Prize carbon removal prize was brought up, and I saw that a month or so ago, the winners. I wrote an email that some people here got. It's absolutely ridiculous and sad. The winner, Meta Carbon in India, is a wonderful company, but they won the prize because the judges were very impressed that they were confident. Meta Carbon in India was confident that they could bring down 100 million tons of carbon by 2040. Russ George brought down 100 million tons of CO2 and repurposed the carbon into sea life in one season, one ocean pasture. And for 50 cents per acre, he brought 12.4 million acres into stewardship. Each of those acres brought down about 6 tons of CO2, repurposed the carbon into living carbon for less than 50 cents an acre. So that's less than 10 cents per ton of CO2 brought down. That's why really the only efficient way to start cooling off the planet, bring back abundance, heal the oceans, is through iron replenishment. That also starts, once it's scaled up, then it buys time for all of the very, very important land-based and other ocean-based solutions. But if we don't start bringing it down really quickly, we're going to just be cooked. We're going to go over the literal deadline. Thank you.
Thank you, Russ, for that contribution. I think it's an important way, but we're going to need all 8 cylinders running on our vehicle to do emissions to zero, carbon removal, and climate repair. And so I would look not only to iron, but to other approaches to regenerate the ecosystems that we're going to need running on full speed on land and on the sea. So thank you.
So, George, was it Dale Welkeman that you mentioned as joining us, that you invited?
Terrence Patrick Long.
Oh, Terrence, would Terrence like to just reintroduce himself, say a few words, since you're new to the scene for me?
Okay. Thank you. Can you hear me?
Yes.
Okay. Thank you very much.
Sure.
My name is Terrence Long. I'm a retired military engineer, explosive ordnance disposal, and chemical weapons expert. I spent most of my life working on landmines around the world, cleaning them up. For the past 25 years, I've been working on what I call underwater munitions. Back in 1910, started in the English Channel, the dumping of chemical weapons that was followed by the destruction of the oyster fisheries. That process was carried out by most militaries of the world up until the mid-1970s. Basically, every sea in the world is polluted with large quantities of these different types of chemical and conventional munitions. It's very interesting what I'm hearing today. I just kind of got invited in by George, and I appreciate that, George. And I'm hearing things about iron and carbon and nitrates and different types of things like that. Basically, what I'm hearing is what a munition is made out of. And when you start talking about the different sites, where are they decaying, where are they not decaying, all of a sudden a thought is going in my mind that was never there before, is that maybe in some particular areas, the decaying of these weapons might be beneficial to the ecosystem or might not. But it certainly looks like a case-by-case study. So what I've been doing is I've been trying to work with different countries around the world at the Chemical Weapons Convention on the SDGs, particularly SDG 14, Life Below Water. These munitions, where they're strategically located in basically every sea in the ocean, they're releasing chemicals 24/7. Even while we're talking here, they're releasing chemicals. And these chemicals actually are begun to meet up with one another. And when they meet with one another, what they do is they cause anoxic zones, mass fish kills in the ocean. This has been documented at a few different places. And how I basically see it sort of on the international scale is we're starting to look at plastic, and governments are pushing that plastic, and totally agree that we have to. But at the same time, we have the weapons that have been dumped in the ocean, and they are government responsibility. It's the government, the militaries, that put them there. And so what I'm faced with, I'm faced with trying to do something on a global scale. And I've been somewhat successful by hosting international dialogues and bringing together the international community. We've had people at some of our dialogues from the Pentagon, from NOAA, from CDC, different types of places like that. In fact, from the Pentagon, they organized a panel at the Center for Disease Control on the weapons. And basically, at the end of the day, there was two sides to the panel. There was those who were receiving funds from the government that said they were all okay, and those who were not receiving funds basically said they were a major issue. So when you look at cleaning them up, it's an expensive process in some places. The first thing we need to do is survey these oceans to identify the scope of the problem. We truly haven't even been able to do that. So for an example, I live in Cape Breton. There's a lake here. It's called the Bedore Lake. It's famous to us here locally because Alexander Graham Bell spent more than a dozen years there doing research and development. He developed the first hydrofoils for the U.S. military. So in that lake, there's 5 sites. One's a chemical weapons site. One's an underwater experimental torpedo range. The other ones are bombing range. And it's a UNESCO protected site. And what I started to find out around the world is after I did some presentations at the Osborne Commission and the Helsinki Commission in Europe, the UN put a program in and started designating a lot of munition sites as marine protected areas. So basically, nobody can go in there. The only problem about not going in there and doing anything is we really don't study it, and the munitions continue to degrade. There's been a lot of study done in Europe, particularly the Baltic Sea and the North Sea. I wrote the risk assessment for both of them. All the Baltic Sea ministers have agreed that they are going to clean up the Baltic Sea. But when you start to look at the United States or you look at Canada, there's a definite policy of out of sight, out of mind. Let's not, even talk about them. So I'm just sort of a one person response to this right now. It's been very difficult moving forward. Every time I think I get closer to funding, I find out I'm not. I received letters from our minister for climate saying that I should be given access to a portion of $680 million that was being transferred from our federal government to our provincial government for climate. And that's setting up a science and technology center to work with everybody around the world on the munitions, developing new and emerging technologies and lessons learned and training and so on, was real viable. But when the time came for the premier to do that transfer of the funds, we never saw nothing. We've had accreditations done by the National Research Council of Canada, which is our Academy of Sciences, saying that we are the go-to organization. But yet we've been not able to get any funds. The reality is a lot of what we're trying to do is being duplicated by the government with the private sector, which what I would call oligarchs, to where just in one cash flow alone, the private sector got $990 million to develop their own technology. And when we looked at climate, we ended up getting nothing. So I don't want to sound discouraging, but I truly believe, and this is my own personal mission, and it's something I'm going to do till the day I die, that the ocean will die if we don't address these munitions. It's something similar to the plastic and the films and stuff like that. They're very destructive. They're destructive enough that they can destroy the ocean. If you look at putting chemicals in the water from the decaying munitions, that alone has the ability to change the temperature and the acidity of the water. We have documented the TNTs bleaching and killing the corals. We found cancers and tumors in the codfish in munition sites, and outside the munition sites, we found nothing. We found that the first thing they do is they attack the photosynthesis plankton and, the very essence of life. And this was first documented again back in the early 1910s. But even NATO documented this in 1996, saying that was a major concern and that they believed by the year 2005, toxic releases would begin to meet one another in the ocean, creating mass fish kills. We've had that same thing repeat itself with different science, but yet we have no action because at the end of the day, it's a government ownership and, not a personal or a public ownership. And thank you for the time.
Thank you very much, Terrence, because you're bringing something that, of course, is, like you say, not out of sight, out of mind. They don't want to talk about it. This definitely gives us something to add to our list of recommendations and so thank you for bringing that to our attention. Obviously, it needs a lot of work, but we are down to our last few minutes. So I see Brian and Louise have their hands up. They can maybe make a brief comment. I would like to end, Leo may have something as well, but I'd like to end with where do we go moving forward? Just a couple of minutes on that at the end here. So, Brian?
Yes. Well, thank you, Terrence, for that articulate description of the chemical hazards in the ocean. I'm reminded of the neurotoxins developed and used during World War II that turned into, after the war, they converted into pesticides, including DDT, that was used extensively. Now, around the early 1970s, they developed a ban on dumping of DDT, and a few months ahead of time, off the coast of California, they took drums and drums and drums of DDT and dropped them in the deep ocean. And of course, those have rusted and leaked. And now we've got DDT spreading out across the ocean floor in these deep waters and having a profound effect on benthic sea life. So there's another example where we're seeing the results of these munition dumps happening, and it's having a profound effect on our oceans and our sea life. So it's something that we need to be aware of and actually work to address. These are the kind of problems we need to focus on to regenerate a healthy ocean and a healthy climate. Thanks.
Louise?
I think Russ Spear is next. And then I can
okay. Well, I don't know if Russ's hands was up from before.
That's
Oh,
up.
okay.
No, it's up for now. Just something really quick. If you do we talked about brightening the earth to reflect more and actually also to shade the ocean. If you do a really deep dive into that, which Russ George has done, you find out that if you get the cloud cover that over the oceans that we had back in 1978, 50 years ago, that has the cooling power that is 1.4 times greater than the warming power of all the CO2 that goes up. So again, if you can, each project adds cloud cover also over the oceans, and if you once you do enough of that, it's a double whammy. It's bringing down the CO2, repurposing that carbon into sea life, but it's also shading the ocean and reflecting huge amounts. Again, it'll cool. It has the cooling power of 1.4 times the warming power of the gigatons of CO2 that are going up today. Thank you.
Yeah, that's right. Spot on, Russ. 1% for the Earth, and we can actually re-brighten our planet in so many ways. And, a very small effect. This is nature. This is the open planet Earth, the way that nature cools itself. And these marine clouds, we have to make sure we can re-brighten from where we were just in the last few decades. Thanks.
Thank you. One thing that comes to mind, Terrence, is when you were talking was things that I learned from our staff biologist at BioDiversity for Livable Climate, Jim Laurie, who worked with their chemical treatment plants to detoxify their chemicals and to actually create water that they could actually discharge into the land. And he used John Todd's method and learned from John Todd that it's just putting a variety of various species, just continuing to load biodiversity in all different forms, no special recipe, into these sequential tanks where he would sequentially detoxify the water, the chemicals coming out of the treatment plant, and got it to a place where it was just water that could be discharged into the land. And so that just what comes to mind is, the restoration of biodiversity and how what Jim and John Todd say is it's self-organizing. So just brainstorming on solutions to these chemicals and how Jim Laurie has taught us that, things just, the microbes and the biodiversity just keep breaking things down into usable components and then repurpose it. So I don't know if that holds promise for the big challenge you're talking about, but it's just a thought.
I thank you for that, and I do understand what you're saying. That's why I kind of alluded a couple of minutes ago to iron and nitrate, hearing that and looking at it from a little different perspective.
Right.
But at the end of the day, it's, do we leave them or do we haul them up? Maybe in particular areas they can be left and they are going to be good for the ecosystem. But in general, what we found, for an example, the mustard gas breaks down to inorganic arsenic and it spreads across the seafloor, killing all in its wake. So that particular, some of the items. The other problem is when the militaries dumped this, it was international protocol and dumping operations, and there's different studies about it. And what you see is the militaries took the opportunity to dump anything they didn't want, any chemical, any equipment, and they virtually just dumped it. I visit one site off of Newfoundland here in Canada, and it's actually 130 tons of U.S. nuclear waste mixed in with a conventional dump site. So I was able to go to College Park in Washington, find all the historical documents, track down the ship logs, what was dumped, where was dumped, who dumped it. And then I actually went into this site and I did core samples, and I found elevated levels of nuclear isotopes well above naturally occurring. So it's a complete mess out there. And the problem with the mess is mixing, and we're not doing about it. So while we're studying in Europe, we're not doing nothing in North America. Zero. We're not even studying the impact. So when we look at all these climate models and we don't include this, Everything is in vain until it's included.
Hey, well, I'd just like to, closing comments is we'll look at, go through this recordings here and see how many different things we can pull out that we could use for recommendations. And of course, the conversation will have to continue because we're just barely scratching the surface. And I know that Phoebe Barnard wants to do another one of these in summer, and she wants to pull out the stops and make it bigger and better, et cetera. So she will be building on this, and so we definitely will be back and covering more of this. And speaking up for the terrestrial bioregions of the world, I will just also say that we can help with the brightening and the cloud formation as well. And I'm doing another master class June 26th, I believe, is it, Leo, on medicinal agroforestry systems. So I'm really big on agroforestry and taking a lot more agricultural land and putting it into agroforestry. And so I'll be talking about that. I think, I don't know if there's any housekeeping from John or Leo, but I don't know who this person that says For the Oceans that's on the call here, and all of a sudden it's like maybe he should say something as before we're out of here. But let's do our protocol first. I know we're going to wrap up here, but Leo or John want to add anything going?
No, I would invite people to put if you're not already an ARA member, please put your email addresses into the chat. I will send you this recording with transcript and AI, and we would be pleased to have you join the EcoRestoration Alliance. I believe that For the Oceans is George Sendero, and if you'd like to say a word of hello, this would be your moment.
You're muted.
Okay, now yes.
Yes.
Good morning. Thank you very much for the invitation, and I'm so sorry to come so late into the meeting. I would have loved to participate from the beginning, but well, it's we have different times. I'm in Costa Rica and working very hard until late in the night, so I couldn't get up earlier this morning. But pleased to be here to hear what I was hearing and continue being together with you. The more information I could get from each of you, it would be fantastic. And I will also write my information, so that you get to know a little bit more about us, what we're doing, and what has been our participation, for example, now in COP in NISA, even if we are not there. But lots of things that would have been nice to talk and discuss today about this meeting, about this summit, and the nothing doing for the oceans in the world, or very little.
So you are on our radar now, and we can look forward to having you in the next Ocean Restoration Masterclass.
Thank you. Thank you very much.
Well, thank you, everybody. I'm going to leave the chat open and the Zoom open for a few minutes for people to put in their contact information. And I will distribute the recording and the transcript and the link to our existing white paper, which would benefit greatly from new information. For example, this munitions story is one that we didn't consider, and it sounds like really an important issue. Thank you, everybody.